This is Jean Pillow. Um, I'm with the Eastern Connecticut Conservation District, and tonight we're giving a workshop on cold water stream habitat and why is it so significant in the healthy watershed. We have a couple of etiquette protocols to ask you to do. We'd like you to keep your video and mic turned off. This will help to preserve bandwidth for the presenters. If you have a question, either touch the screen with your mouse, or if it's a touch screen, you should come up as chat so you can see the chat. Then you can type in your question, and I will see it, and then we will respond to your question. I'd like everybody to practice using chat by telling me how many people are at your viewing station. So press chat and say who you are and where you're from. Okay, we're probably going to hold off on asking questions till the end of the presentation, but if there's something that I think is good, I'll interrupt Chris and Mary and have them answer the question then. This program is being recorded, and it will be posted to the ECCD website by next week, and other resources that we talk about here will also be available to you. So, move on to the next screen. So this program is because the ECCD is under contract with the Connecticut DEEP to develop an Upper Natchitoches Healthy Watershed Implementation Plan. I'm the project lead, but all our staff are involved in this project in some capacity. And we're also working in partnership with Connecticut DEEP and the towns of Ashford, Eastford, Chaplin, Mansfield Union, Willington, Wyndham, and Woodstock, all the towns in the watershed, and many other partners too. Eastern Connecticut Conservation District is one of 5 conservation districts in the state of Connecticut. We're all quasi-governmental organizations, meaning we were created by state statute. We have rules and roles to play in the state. On focusing on soil and water conservation. We all have our unique territories. And we have ways that you can communicate with us through our website. We also, if you want to follow us on Facebook or Instagram, we have an account there too. So the Clean Water Act was passed in 1972. The purpose to bring all water up to Class B, which is swimmable, fishable quality. This requires water quality monitoring and reporting. That's done by Connecticut DEEP. It also requires the states to make plans to restore impaired streams. 2009, they took a new focus, and instead of focusing on only the waters that are impaired, they are now also focused on the watersheds that are more healthy to keep them from getting polluted. And so the Natchitoches River has been classified as one of the healthier watersheds in the state of Connecticut. It's not pristine, but it is one of the healthier watersheds. So what makes it healthy? Its landscape condition, it's 74% forested, its habitat condition, there's a lot of core forest areas that are helping to protect water quality. The hydrology, the streams are mostly free flowing, although there's many dams. The landscape form is not grossly shaped by humans. I mean, we do have road cuts and such that do change the landscape form, but it's pretty intact. Water quality is not perfect. There are some issues, but it's better than other parts of the state. And the aquatic habitat condition is relatively unimpaired. So that's pretty good in the state of Connecticut. It's a benchmark stream in Eastern Connecticut because as a large watershed, especially above Mansfield Hollow Dam, the only sources of pollution that should be going into this watershed are from non-point sources. There are no municipal discharges or industrial discharges. So this is the NatChog. There was a big process that was used to choose which watersheds would be the primary focus of this project. The special tool that was delivered by EPA, they looked at ecological indicators, social indicators, stressor indicators, and they came up with a mathematical way to compare watersheds. And the NatChog and Mount Hope River scored high on this scale. And this is the first watershed in Connecticut that's being focused on for a healthy watershed plan. We're trying to identify where things are not polluted, find cost-effective ways to maintain this watershed or return it to its better condition, using a lot of community outreach, including this particular workshop, to build awareness of the ecosystem and the ecosystem services. And with that community input, we are going to put together this plan on what strategies we can do for anti-degradation measures. And then there'll be a schedule and measures and all that in the plan that we will develop by the end of August. And you're invited to become involved. There's many different ways you can. If you would like to follow us on Facebook, we developed a special Facebook account for this project called Naturally NatChog. We also have an Instagram account at Naturally NatChog. The Eastern Connecticut Conservation District has a website. All the documents that are being produced for this project are being posted on our website, so they're available. We're being very transparent with all the conversations we're having. All the water quality investigations we're doing, people are involved in that. Sorry. We also have a newsletter which you can sign up for on our website, or you can just email me at jean.pillow@comcast.net. So that's enough of an introduction. Now I'm going to introduce our evening's presenters. Chris Bellucci is the supervisor of the Water Monitoring and Assessment Program at Connecticut DEEP, and Mary Becker is an environmental analyst 3, also in that same program with Chris. They have been involved in collecting a lot of data and doing a lot of research to categorize the waters for aquatic life use support, new programs for using stream diatoms to determine phosphorus levels. Great stuff going on, but they've been focusing on cold water habitat and developing mapping to make these things available to people. And I'm going to turn the program over to them. I'm going to stop sharing and stop talking, and I'll let them take over. Can you share your screen, Chris? No.
Chris, can't unmute yourself?
Can you hear me now?
Yeah.
Can you share?
Okay.
Is it working? Can you get it to share? There we go.
See that?
Yep.
I do.
All right. We're getting good at this Zoom stuff, Gene.
Hey, I saw that graphic a little while ago.
Yeah. Does that work? Can you see that, or does it get cut off?
Perfect.
I'm seeing it perfect.
Okay. Well, thank you, Gene, and thank you everyone for attending tonight. Mary and I are happy to present this information that we've been working on cold water stream habitat. At some point here, I'd like to share, have Mary share her screen, so that'll come in a bit. But I think what I can do is kick us off and sort of introduce the topic, and then some of the background on the data we've been collecting and how we came up with thresholds to look at cold water habitat, stream habitat in the state, and then I'll hand it over to Mary, who came up with a really cool web application that you can zoom in, see your favorite water, get the data that's associated with the map, and I think you'll be impressed with the application. So let me start by just outlining what we're going to do. It's two-part. Part one is sort of the background, like how we came up with the data collection to come up with the summer thermal thresholds. We used basically our fish data that we collected both in our group and with the fisheries division. We have a good fortune of working with our fisheries folks, and we pool all our data together in a big data set in which we can evaluate all together for cool things like this. And a bunch of years ago, we published a paper that kind of outlined what I'll talk about a little bit today. And I'll have a link to that publication if you want more in-depth information on that. And then sort of part two gets into, when I'll hand it off to Mary, is sort of like how we took those thresholds, applied it to all the data that we have for streams, and developed the mapping application that we'll show you. So in order to do the background that to come up with water temperature categories, we looked at stream sites throughout the states where we had continuous temperature monitoring with these hobo data loggers that we deploy. And that coupled with where we had fish community data during the same year at the same time. So that was kind of the data mining that we did in the beginning to kind of look at what these categories for stream temperature might be. And when we took a look at that, we had 160 sites throughout the state, pretty well distributed throughout, as you see there on the map. The triangles are sites where we had co-located fish data and water temperature data. And at the bottom of the screen, you see a reference to the publication I was talking about earlier. Gene and everybody else, I'm welcome to, I'll share the slides with you after, and you can send them around, and then everybody will have this information. So to sort of cut to the chase, we basically put the information together, and then we applied some statistical techniques to try to come up with thresholds. We use a technique called Titan, or Threshold Indicator Tax Analysis. It's a statistical technique. I'm not going to talk a lot about Titan, but just to raise your awareness of how we did this. And when we did that, we came up with sort of 3 temperature bins: a cold, a cool, and a warm. And here you see 3 metrics that we came up with: maximum daily temperature, July mean temperature, and then sort of a summer June through August temperature. And the temperatures in degrees Celsius on where these cutoffs were. And what the Titan analysis does is it looks at the fish community coupled with the temperature logger data that we had. And it also will help us indicate, for each temperature category, show us indicator fish species. So that's a kind of a neat aspect to it. And for cold water, slimy sculpin and brook trout were the 2 indicator fish species. And then in the cool range, we didn't really have any solid indicators. And then in warm water, we had species like cutlet minnow, smallmouth bass, and the other species you see there as indicators. But we're going to focus, obviously, the focus of this talk is on the cold, and I'll be honing in on sort of those thresholds and those indicator species that you see under cold. I'm going to step back a little and just talk about, these are just scatter plots. So Over here, you see the number of fish per 100 meters. So we made all the data sets consistent to be reporting per 100 meters to make the data consistent from stream to stream. And then these are temperature values. And we're going to focus a little bit on that same metric, that summer metric that I mentioned before. And I'm going to show you a bunch of plots here. And these are all the same, set up the same way in the June through August mean temperature on the X, and then fish per 100 meter here. And this is an example of two species that we see pretty much everywhere that we go in the state, black-nosed dace and white sucker. And you see by their abundance as recognized by all these dots on the scatter plots that they don't really have a preference for any temperature. They're kind of all over the place. So that's a good example of two species that don't really have a temperature preference in streams. Whereas these two species, and again, the plots are the same, the June through August average or mean water temperature and the density of the fish on this axis. These are two species where if you look at the temperature, once you get to this kind of cutoff, you see that they're more abundant as the temperature of the stream gets warmer. So red-breast sunfish and smallmouth bass were two of those species where you notice from the table that we had in the beginning are indicators of warm water streams in the state. And then we had some species that we kind of call the tweeners that kind of didn't have any, they didn't fall clearly in either of the bins. Brown trout and American eel were two of those examples. I think the brown trout would tend to be more on the colder side, but they weren't a cold water indicator. And American eel, they probably would fall a little bit more towards the warm, but neither of them were a statistically significant indicator species. And now we're kind of getting to the stars of the show here, the cold water species, the brook trout and the slimy sculpin, and kind of the same plots again. And you'll see that their abundance is much greater under the cold water stream temperatures. And so therefore they were statistically significant indicator species. And just to kind of emphasize the significance of that. So now we have two ways to identify cold water habitat in Connecticut. One is by temperature, and one is by cold water indicator fish species. So I want to take a step back and talk a little bit about the two fish species. So brook trout, we've been kind of looking at healthy waters for a while, as Jean mentioned in her introduction. And historically, our department has focused a lot of its water quality monitoring effort sort of on this. If you look at the graph, this is sort of a stressor gradient, any, plug in any stressor that you would like, and then this is sort of biological condition. So things that plot on this upper end are sort of the least low stress, highly natural streams, and sort of just a conceptual model to visualize some of this. And then the streams that would plot down here, excuse me, are highly stressed, and their biological condition is not as great. And historically, our department has focused a lot of its effort on a lot of the streams that sort of needed the most help at the time. A lot of these are classically what you guys might think of as impaired streams. But as we started to get a better handle on those type of streams and get better treatment over the years, and as we started seeing them improve, we focused a portion of our resources and time into looking at sort of this area where streams were less stressed and more natural, and trying to sort of map out where in the state these places would be. And we did a study back in 2011, and it kind of emphasized what we knew, but it did it in a sort of way where we honed in on it, did some statistics, and brook trout were really one of the species that came out truly as sort of a sentinel species for these small, least disturbed streams in the state. And then a little bit about our other cold water indicated as slimy sculpin. The sculpins are in the coded family of fish, and there's a lot of species. They tend to be mostly marine, and the slimy sculpin is our native sculpin species, and they're really a small, nondescript species. You'll see this guy here. It's almost hard to detect that he's even there. They're very well camouflaged, and for the most part, slimy sculpin is the sculpin that we had until recently. I just bring this to your attention for those fish buffs on the talk here. We recently found, we don't often find new species in our fish work, but we recently found in the Pomperaug Basin over east, this species called a knobfin sculpin. It's a little bit bigger than the slimy. It's native to actually Arkansas, and I think our current running theory is it probably came into the state probably through the bait trade, through the bait and tackle shops. I know they get a lot of their shiners and minnows that they sell to the anglers from down in the Arkansas area, and that's kind of what we're thinking. So just a kind of a tidbit of information on this knobfin sculpin. Like I said, we don't typically get new species in the state. Right now, it's exclusively found in the Pomperaug, and we're keeping an eye on it to see if it expands its range. They don't have they're not a strong swimmer. They're not going to get up over barriers, so it's tough to tell how far and widespread they might go, but nevertheless, we are keeping an eye on them. So those are our two stars, the slimy sculpin primarily and the brook trout. And this is a map here that kind of looks at these two species and their occurrence and some of the mapping that we're going to show you, that Mary's going to show you a little bit later. But these sort of bubbles are, the size of the bubble shows how dense these fish are. And the bigger the bubble, the more fish that we have on these sites. And you can see sort of a pattern that the western sort of uplands and the eastern uplands, there's a lot of these, and then we have sort of pockets in here and then pockets down here, but along the heavily developed corridor along 95 and the central part of the state, not so much cold water habitat. So I want to talk a little bit about how I mentioned before, so we have this work where we developed the temperature thresholds in the fish species, and we're very fortunate to have very well managed data sets from folks like Mary, who do a great job at managing this. And you'll see here, I'll talk about this. These are just spreadsheets that we set up to take a look at this. And up here you have the years. So this is 1988, 89, 90, all the way up until sort of the present. And the way to look at these is, here's an example of Valley Brook, Mott Hill Brook, and Rug Brook. And we have sort of three categories that we use in the spreadsheet. So the dark blue are sites that we had greater than 10 fish per 100 cold water fish per 100 meters, and we put the density, the number in there. So for example, this is 153 cold water species collected in 1988 at Valley Brook. So we're able to look at it over time in sort of a really easy way to sort of evaluate. And these three streams are easy because they're always cold and they always have a fairly high density. But we also have these other two categories where we have, some cold water fish, so less than 10. So we colored it up this other color blue. And then we also have sites where we have no cold water fish and we colored it up gray. So these are kind of a slam dunk as far as being cold water streams. Every time we've been there, we've measured it, it's been cold, fairly high densities. But, it's biological data. So as we know, that it never always conforms to the patterns that we would hope they would. And sometimes they flip flop, and sometimes, they go from being, for example, Patton Brook, we didn't have any cold water species. In 95, we actually had 46, and then it dropped down in 2007 to 0. So there's different patterns that we looked at when we started to evaluate data to try to come up with a good method to see what we would put on the map to identify it as cold water habitat. So these are fish densities plotted here, and we also did a similar type analysis for temperature. You might imagine that we can do a similar exercise where we're plotting the cold water metrics, for example, that summer metric that I showed you earlier, and whether or not it was consistently cold or whether or not it flip-flopped. We looked at that as well. I'm not going to show you that, but I just wanted to point that out. And since we have these two different ways to map things, for example, the fish community stuff that I was just explaining with these two indicator species, but also temperature, looking at sort of that average threshold for summer temperature being below, 18.29 C. That's sort of these cold water streams here on this box plot. What we decided to do was we included all data where we've measured it cold ever. And what, our sort of rationale for doing that was the data are available for everybody to sort of use it in whatever fashion they think is useful for them. And they can dig into the data and see whether or not the signal is strong enough to use for your whatever decision you want to make. So for the time being, our map basically publishes everything that either meets one of these criteria that has ever been measured by either our data or volunteer data or fisheries data. So as I mentioned, we are very, very fortunate in a bitty state like Connecticut. We have a very dense dense network of stream monitoring locations. This gives you an idea of what goes into this map. So for fish community samples only, from 1998 to 2019, 711 sites, 914 samples. So it's pretty extensive coverage. And then for water temperature, our data spans 2002 to 2019. In the early days, they didn't really have these hobo data loggers, and that's why you see that data missing. And then they became fairly inexpensive and easy to get. And then as soon as we caught on to that, roughly around 2002 is when we started pretty widespread deployment of hobo temperature loggers. So 103 sites, 268 samples. And just to describe a little bit about how we decided, once we had a sampling location that we identified is either with the fish or the temperature logger information as being cold, as represented by this sampling location here, the question became, what part of the watershed do you include? And so what we did is we included the entire upstream watershed from any site where we identified it as cold. And when you put that all together in a map, as you see here, we have roughly 4,000 stream miles in the state that, you know, using this methodology that we identify as cold water stream habitat. And if you want to look at an aerial basis, it's about 1,600 square miles. And what I'd like to do for a minute, if I could switch before I hand it over to Mary. Could you guys see that now that I switched? Somebody nod their head. Yes? Okay. So this is the website where this information is. Okay.
I'm still seeing the map that you had up. I didn't see the switch.
I might have to do a couple moves here.
Yeah, you have to take down and then put up the share again. While you're doing that, I'm going to ask a quick survey question. I've already asked that question. How do we get to the other question? All right, if you're a volunteer, here's the question. If you're a volunteer on a municipal land use or conservation commission, which commission do you serve on? Okay, we had 23 people respond, or 11 people are on commissions, 5 are on inland wetlands, and 6 are on conservation. So thank you for participating in the poll.
Gene, you'll have to show me how you do that.
We'll talk another day. It took me a while.
Yeah. So this is just pointing to the department's website where some of the background information that I have described here is written down for you to take a look at. You know, the background and link to some of the literature that I was talking about, the map, and then some the fish species that we were describing, and sort of the methodology behind it, you know, kind of like a Cliff Notes version of what I went over today. And then this is kind of really the nuts and bolts of how this thing works. And this is the cold water stream habitat map application that Mary developed. And I think at this point, now that you guys know that this is here, if you Google cold water stream habitat Connecticut Deep, you'll find this. I think it'll come up fairly easily. But I'll hand it over to Mary and she can take you through the map app and drill down to some of how it works. And then I think we could probably take questions from you guys. So I'll stop sharing it and hopefully Mary will be able to share her screen. And Mary needs to be able to talk too.
Oh, sorry.
Okay, can you guys hear me now?
Can hear you.
Okay, great. All right, let me see here. Okay, and are you seeing the map now?
Yes.
Okay, great. Excellent. So when you go to the web link off of our main Connecticut Deep page, you'll come here and it will open up on a statewide view that's showing, you know, close to those 700 sites that we've identified as cold. And like Chris said, you know, and kind of where most of the work is getting all this data together. So we have data that was collected by the monitoring group, Fishers group, and then folks like Gene at the Eastern Conservation District that have arranged this data, you know, very nicely so that we're actually able to put it all together on this map. So all of that information is compiled here, and each of those dots is representing where we've actually collected either a fish or temperature or both at a particular site in a stream. And then the blue area here is that upstream watershed that Chris was talking about that we delineated to represent the areas that are supporting those cold water habitat, those cold water sites, and areas that we would want to protect to hope to keep those waters cold. So it is a web application. So what you can do is just kind of zoom in here. And then we can select a site. So here we have Mott Hill Brook. So it's one of those places that we find that are always cold, and we have both temperature and fish information. So you're able to kind of see visually where that is in the state. Click on the sampling location, and it gives you information about the data behind that particular site. So in this case, we had temperature loggers out there for 9 years and fish samples from 6 years, all indicating that that was cold. And since you guys are Natchog Basin, we can kind of zoom over here to see what kind of data we have here. So we've got a bunch of tribs going into the Natchog Basin where we have some information here about cold water. So we have places like East Branch Stonehouse Brook where we have some fish samples that indicate where we either got those brook trout or slimy sculpin. And up here in Goodwin Brook, again, some more fish samples that were taken. So you can kind of zoom around the basin and take a look at the information on places and the supporting drainage areas on where we have that cold water information. Then in addition, you can either click on this link to data or go to this download data page. And here is where you can get all of that information that went into the map. So it includes a CSV file that you can open up in Excel or whatever spreadsheet program you want to use. And you'll be able to get all of the information like the fish data. So how many fish per 100 meters were we finding for a particular year, or how many years of that temperature data that we have, and what were the values we were finding. All of that's contained here in that sampling data CSV. Then in addition, we also have the static map that you can download if that is helpful for you. We also have the spatial data, the information, so both the sites and the watershed areas. So this information that went into the map, and then we even have a link to, if you want to see how the map itself, the application was developed, you can go there and find that information as well. And then this about page will just bring you back to that, the Connecticut D page that has, again, some of the more detailed information that Chris was talking about previously. So, so that's it in a nutshell. I can either hand it back to Chris, or we could, if people have questions specifically on the map, we can chat about that now. It's up to Chris or Jean, whatever you guys want to do.
Chris, do you want to move on from here, or do you want to ask some questions? Let's have people ask some questions. If anybody has questions, you can ask them in chat, and I will relay them. I have a question. How do you envision this cold water stream mapping data to be used? Is there any limitations that users should be aware of? I
guess, so the the one thing, we'll note is that this is kind of a living map, right? So as we collect more information, it will continue to grow. If we find, places as, when you put together this amount of data, occasionally you might find a place that maybe shouldn't be on the map. So we'll occasionally correct things. But for the most part, we've done some pretty rigorous QC to make sure that what's on here is good information. But there's always that caveat whenever you're using information, particularly information of this size. But the main point is that as we collect more information, we'll be putting that on and updating this map as we get more information in.
Okay, here's a question from George. How many water systems contain naturally occurring and breeding brook trout populations? Are they widespread or infrequent?
Well, one thing I'm not sure if Chris mentioned this, but we used a cutoff of 10 cold water fish per 100 meter. So instead of just using any place that we had brook trout, we tried to identify those places that had naturally, reproducing populations. So that's why we used kind of a little bit higher cutoff for the brook trout. And, Chris can correct me if I'm saying anything incorrect because he's the fish biologist.
Here's a question from John can we see the temps of rivers where you have your device? I don't know what that means.
So yeah, if you, if I'm understanding it correctly, if you go to that CSV file and open it up, it will have, so what we used was a metric, the summer mean temperature is what we used, as Chris talked about in the presentation. And so in that CSV file, you should be able to get the all of the temperature data and the temperature readings right in that file.
There's also the sheds database that has the temperature data in it. I believe you can download the data from that site. As for volunteer data is, I know the data that Last Green Valley collects gets shared on the sheds site. I can send a link to that or post a link to that later. Question from Gwen. What percentage of the areas around cold water streams are protected? I think that means our cold water streams, so they have a higher level of protection. Is there, like in Massachusetts, is a designated area around cold water streams of higher protective level regulatory, or is it just a stream that happens to be cold water?
Well, that's a good question. So we're just looking at the data and identifying places, so there isn't really any, regulatory requirements based on this map. So we're identifying those areas. It would be an interesting analysis to try and put together as much of, protected open space areas that we have across the state and see the percentage, but I don't have that information, off the top of my head, or, haven't really dug into that yet, but would be an interesting thing to take a look at.
I don't believe in Connecticut we have the same regulatory oversight for cold water streams as they do in Massachusetts, but there are higher standards in cold water streams for regulation purposes in Massachusetts. Let me see if I can come up with the next question. Can you comment on Merritt Brook and what you have found? This is a person who fishes in it regularly, and this person sees less fish than before.
You've seen less. You've seen less
He's
fish.
seen less fish than before.
Okay. Yeah. I mean, I know Merritt Brook is definitely on here. I would have to, you guys could definitely dig into the data and take a look to see see what kind of numbers that we're getting when we go out to sample there. I know we definitely have quite a number of fish samples in parts of
That'll be a very
Manitoba.
good use of this map and this data.
Yeah.
Here's a question from Eric. Do we have local air temperature data collected with the water temperature data?
Only at a few sites, right, Chris? I mean, we don't routinely collect air temperature data and water temperature data. But we have it at a few sites, not
Yeah,
many of them.
I would say a handful of sites throughout the state have paired air and water temperature. And we know of other studies that have looked at that very closely and a very high spatial resolution too. There was a doctoral student who finished up at UConn, Yoichiro, that was actually helped us write the initial paper. He did a lot of work on that, and we can share that with you, Eric.
Okay. This is from Lee. A recent article in Connecticut Wildlife suggested brook trout are disappearing from many Connecticut streams. Do you want to comment on that?
Yeah, I think we have a few slides following the map application that will show you that gets to that question, and we're interested in exploring that too. We definitely see in some cases densities getting less at certain sites over time. And we have the fortune of having these, long-term data sets going back to the 80s, which for us is a great gold mine. And we're looking at that right now, actually. And before, I couldn't talk before because I was muted, but the person that had a question about wild trout, I should have mentioned this earlier when I was talking about brook trout. All the brook trout that are in this map and were used to map it are wild brook trout. These are not stocked fish, and we know the difference in the field and can tell the difference, and we haven't included stocked fish in this analysis at all.
Okay. I don't see any more questions, so do you want to continue on with your presentation?
Sure, we have a few more slides. And let me have to. Okay, is that back up now?
Nope. We're seeing Mary Ellen's screen. So Mary Ellen has to turn her screen share off.
Oh, Mary, are you still sharing?
It says Mary Ellen, not Mary.
Oh, Mary Ellen.
So Mary Ellen, if you have your screen sharing on, you have to touch your screen and go down to the bottom and say stop sharing. There we go.
Okay.
Now you can share.
Gotcha. Got that
I see it.
back? Okay, back in action here. So just a few summary slides, and then I guess we'll get into a little bit to the discussion, some of the questions that were, in particular, like Lee had. So, just to emphasize, again, brook trout and slimy sculpin, they are the heroes of cold water streams in the state. And we base this on information from good information that we've collected, both in deep and volunteer information. We've been able to identify the watershed with, thriving, healthy populations of these species and use that to identify important watersheds for cold water habitat. In addition to fish, as I was describing earlier, we can also use temperature by itself to identify cold water now that we know these important temperatures for these stream fish, and we have roughly 4,000 miles of cold water streams. And we've given this talk probably close to 10 times now to different groups, and we're happy to do it. and happy to spread the word that this information is available for people to look at and use. And we welcome your feedback. And if you see something that looks kind of funky to you, please let us know. But I want to emphasize that these are all measurements. This isn't a modeling exercise. This is really all based on measurements made in the field by many dedicated people for years and years, both biologists at TEEP and volunteers. And I know in the beginning when we were doing this talk to other groups, there was a little bit of confusion. So I wanted to emphasize these are measured values from streams in the state. So this kind of gets into some of the things that we're thinking about and a little bit about some of the questions we've been getting. And what we have found from our preliminary look at some of this, and if you think back to that slide that I had where we had the sort of spreadsheet and the years on top and the color coding, you start to get patterns. And we're fortunate in having a lot of biologists that have been around for a while that have been working on these streams for years. And we're starting to take a look at it. And we found that roughly 61% of from the fish samples taken at T1, so the first time we measured it, that had a cold water community, at time 2, 20 more years later, it was also cold. So that's kind of an interesting finding that some of these fish populations are very stable. So on the other hand, there are a handful, roughly 15% of the fish and about 13% of the temperature loggers where we measured it during the first time and it was cold, and then we went back and it wasn't cold. So there could be some interesting information to be gleaned from that. So we have observed declines in cold water fish density over time, as Lee suggested, and as the article in the Connecticut Wildlife shows. And the bar chart here just shows the sort of the farther away the samples are, the higher sort of probability, if you will, that there going to be a decrease. And you can think and surmise why that might be. There's development that occurs over the years in some of these watersheds. There's things that can change over 20 to 30 years that might impact that. And then at the other end of the spectrum, the closer you get together, the less likely that the fish are changing. So that's exactly kind of what we want to do next. In terms of our next steps, we want to dig into this and explore it a little bit more. So is it landscape changes? Is it site geology that's making some of these streams real stable? Is it a combination? Is it climate impacts? Or, are we warming? There's lots of things that we're kind of thinking about, and we'd be certainly happy to hear from you guys if you had any ideas on, some of this. We're really, just got to the point where we're putting this together and starting to think of, okay, now what? Now what can we do with some of this and explore it, and perhaps if we find some patterns that are worth, sharing and writing up, we will do so. And so please share your thoughts if you have any. And then one of the things that we found in our earlier publication on this, now if you noticed back to one of the slides when I was showing the cold, cool, and warm, it really doesn't take that much of a change in stream temperature to move a stream from cold to warm. And this is, again, it's average summer water temperature, so it's not just a 3-degree change on any day. It's over that summer period. But if we start to see streams warm, we're going to see some of these cold water habitats not be cold anymore. So, if we care about that, we ought to think about that. And so we started to think about, what what types of things could this map be used for? Now, we're not, we're just putting this out there as ideas, and hopefully you guys have ideas too. But certainly state and local environmental reviews, if cold water habitat is an important habitat for you, this is a great resource to go look at. You can look at your site and look at the map and see if things are close together and see if in fact it is cold water habitat. For land acquisition, for folks interested, for example, we've talked to Nature Conservancy. They're very interested in this application. They're very much in the business of, working with land acquisition type activities. Our state wildlife action plan identifies cold water habitat as an important habitat. So that's a sort of important thing to think about and hang your hat on if you need it. And then this trend and research type idea, I kind of alluded to that. We're starting to look at that. And certainly I think, at this point, if you guys have any ideas or additional questions, I don't think, other than the sort of last slide to really thank, if you've ever done any data collection and management of information, this is a huge effort, and we really have people like Mary and Mike Pusheen and others who have spent, a greater part of their career working really hard behind the scenes and managing this information. But it really allows us to do spatial analysis, things like this. And many of you on this, I don't know if to call it a call or a Zoom, everybody here tonight, I'm sure a lot of you participated and contributed data to that. So we really appreciate it, and just keep it coming, and we'll continue to manage it. And as Mary stated, this is certainly a living, breathing map. Our plan is to update it as we get new information. And now that we have this format and a way to serve it up, and as we get new sites, we certainly will put them on the map as frequently as we can, and continue to improve the map as we go on. So with that, I could take questions, and if you guys can, it would probably be helpful if you can unmute Mary and I at the same time. If there are questions, we'll try to, both of us could help answer the questions.
Let me just check to see if Mary's muted. She's
Thanks, Jane.
okay.
There you go. Yep.
I do have some questions. Let's see. Would it be appropriate to use this database to make judgments about development projects that have high probability to increase stream water temperatures? That I think you've already alluded to, that it's available for that?
It is, and I would just say, I think my recommendation would be to really look hard at the information and see how many years it is. If it's a bunch of years, and it think of things like that when you're trying to evaluate that question for yourself. In other words, if it's 1 year and it was back sampled a long time ago, you might have a little less confidence in it, perhaps. But if we had 9 years of data, like the site that Mary showed you on Mont Hill Brook, I think we had like 9 years of data for fish and 6 of temperature or something. That's a pretty strong signal that that's a cold water stream. So I would encourage you to think of things like that. We really have it out there for you all to decide on how you might use it. But those are the kinds of things I would be thinking about if I had to make that decision.
Okay. How is your sampling scheduled with respect to time and place? Would it be appropriate to ask the department to sample a specific stream?
Yeah, I mean, I think that's a legitimate question. I think there's a couple of things I can offer. One is through the volunteer monitoring program. We're a little out of whack this year due to the COVID situation. Obviously, everybody is. But if it were a normal year, we do have temperature loggers that, you know, I know many of you have your own and deploy. That would be one way to get into an area and try to identify it as a cold water stream. Temperature loggers are fairly cheap these days. They're around about $100 or so, roughly, per unit. And if you deployed it over the summer and made sure you got the summer months and, you know, had good quality control on it, I think we could work with you on that end, and I can share with you Megan Lally's name, and you know, she runs that volunteer temperature program. And then on the flip side, the fish survey, most volunteer type groups don't really do that kind of work, but if it's fish work, certainly if you have interest in that, and the requests are fairly, you know, small, like one site, you know, certainly just email us, and we can work to try to put that kind of stuff on our schedule.
Okay. Is there seasonality in your data? Would that account for the variance, or has data been adjusted for this factor?
Well, I think there's seasonality in the data. If you want to drill down into that a little bit, you could take a look at that publication. Basically, what we found when we did our analysis is the summer is really what differentiates the habitat, right? In the winter, it's probably all cold water habitat because it's all cold water, right? But in the summer, that's when you sort of see this separation between habitat types, because in the summer, it's sort of the limiting factor for the cold. And surprisingly, you know, many of the streams that remain cold are driven by groundwater. They're largely groundwater fed streams, and that's why they remain cold throughout the year. I don't know, Mayor, do you have anything to add on that?
Yeah, no, I would agree with that. And yeah, primary season when we sample for fish, and the temperature metric that we're using is during that summertime period when we see those changes or differences in the streams. So,
Yep.
Yeah.
I noticed that one of the data sets you pointed out where there was a decrease was a drought year. Is that taken into account? Flow?
I mean, even in a drought year and some of the true cold streams, it'll stay, you know, sometimes even be more cold. You'll see more of a, because it's largely groundwater fed streams where we'll see that. But you know, if it's a drought year and for whatever reason the temperature logger's out of the water, then, you know, we would discard that type of data. And with the temperature loggers, we're typically have them in the streams for, you know, multiple years. We generally have a network currently that we're sampling over multiple years.
I know when we set ours out, we try to go 2 years per site minimum.
Yeah.
How do you know you've gotten the right count on the fishes? Do you have a standard operating procedure you use?
I mean, I think the question probably pertains to like how we came up with the 10 and the less than 10. And so our thought on that is we didn't want to include a stream if it just had like 1 or 2, for example. We wanted to make sure that it was a sort of reproducing population of brook trout or sculpin. So we had to evaluate that and try to come up with cutoffs to make sure we were kind of excluding those sites that, you know, might had a stray fish or two. And we kind of looked at that and we came up with, you know, Mary's magic number of 10.
Okay, here's one. Here's one from my friend Cindy. She's from Colorado, now living in Connecticut, and we discovered that even though a stream is cold designated stream, if the springtime temperatures do not get within certain parameters, the brook trout will not spawn. So with climate change, if you have a warm spring, that affects the stream temperature, even though it stays within cold parameters. It can affect spawning.
That is very true. And we also have found that flows, low flow years, particularly around the spawning period in the fall, can also impact the brook trout. In other words, if the stream becomes fragmented and they can't get to the riffle where they need to spawn, that also will affect year classes. And if it happens frequently enough, you know, eventually the population won't be there. So yeah, things like that are important to look at, and that's why we would encourage you to really look at the data and determine the decision that you want to make, and look at the data and make sure it kind of fits your level of scrutiny to make your decision.
Okay. This is a question from an inland wetlands review standpoint. What activities in the upland areas of a stream concern you most that would impact or affect the physical characteristics of the water course?
That is a great question. I mean, the thing that comes to mind is anything you do with the riparian corridor to remove shade, like take trees down. So any development that's going to be within the immediate riparian corridor, I would be very concerned with. That's the first thing that comes to mind. But I'm sure there are others. It's kind of not really our wheelhouse per se. And I know our fisheries division has some guidelines out there on those type of things, riparian corridors, and other things related to that. But we can find it for you and share it with you.
Okay. What about impervious cover, changes of impervious cover in the watershed, which will change the amount of groundwater, you have more runoff, less infiltration? Is that something that we should be considered a big concern?
Yeah, I think I would be concerned with development, imperviousness, and you know, anything that gets you away from natural, I guess, you know.
Okay, I don't see any more. Oh. All right, this someone wants to see an example of what the temperature gauge data looks like. Do you have that handy? Or I mean, John, I can send that to you because I have downloaded data off of Hobo Loggers, so I will leave myself a note.
Yeah, we don't have that, but I mean, in general, what we do is we deploy these in a deep portion of the stream, and we set them to go off every hour. So if you can imagine a data set with a time, you know, 1 o'clock, 2 o'clock, 3 o'clock, and each time there's going to be a temperature recorded. And these data sets, it's really a, you know, a tribute to Mary and the way she can manage these data sets. So you have an hourly temperature measurement at all those sites that you saw. For, you know, if you put it out for a year, you have a lot of data really quickly, and it becomes really challenging to manage it all. And then, of course, what we want to do with that information is make metrics like we have and do analysis, and that's where the kind of the beauty of some of the data management databases that Mary manages come into play, because that allows us to do that kind of work.
Yeah, and the temperature that information that goes into the map, it was summarized from those hourly measurements. And so that information is a summarized summer metric. I mean, I'm happy to show you the CSV file if that's something you wanted to take a look at. But for those hourly measurements, you know, in batches, we're sending that up to the sheds database repository that Jean mentioned earlier, where our volunteer data goes as well.
Yeah, that sheds database is maintained by USGS, UMass, and it's quite a information source. And it's, I know it initially started sort of as a Northeast system, but I think it's expanded well beyond that now. And if you Google sheds, eco shed, do eco sheds, otherwise you'll get a bunch of pictures of sheds. So eco sheds, ECO sheds, and then you will land on that website. And there's a lot of cool applications on there too. They work a lot with brook trout, and you'll see occurrence probability type work, and they have a lot of cool like scenario analysis type tools that they run. So I encourage you to go take a look at that.
Yeah, and I just see in the chat here, we definitely have bloggers in the Naugatuck River and probably the Chautauqua, I would guess. And then USGS also collects temperature data at a bunch of their gauges. So that would be another place to check out for temperature information.
Well, that's about it for the questions. Oh, wait, one more. Have there been any restoration efforts that you have seen be successful?
In terms of temperature, I can't think of any.
Chris, has anybody done an analysis of the Mount Hope River where it goes through a farm where there was 1,000 linear feet of riparian buffer restoration, a before and after, to see if that had an effect?
Do you know, Gene, is that a fisheries project?
It was a fisheries project.
Yeah, it rings a bell. I'm not intimately familiar with it, but I think Brian Murphy would be the one to contact on that. And I'm not sure if he did a before and after hobo type thing or not.
I might be before the days of hobos, but I could be wrong on that.
Yeah, I think you might be right.
All right. So this has been a really interesting presentation. I think we've all got a lot out of it. And again, I will be able to share this presentation in about a week or so. I'll be putting this entire recording up on the website. And if you have questions or you want links, you want to get in touch with Chris or Mary, contact me and I will make sure that your questions are brought to their attention. And we'll get you the information that you are looking for if we have it. So thank you, Chris and Mary, for this great presentation.
Yeah, thank you guys so much for listening.
Yeah, thank you very much.
Okay, well, good night, everybody. Thank you for coming.
Have a good night.
Night.